This is a video for day 3 of Solving Rational. We're going to be doing applications today. So we're taking a look at we're just going to do one type. If we were in school, we'd be doing several different types of distance, rate, time ones. I'm going to just stick to one type. We're going to do one example and then do 2 practice problems based off of that example. So we're going to keep it pretty narrow. So what we're looking at is a speedboat can travel 32 miles per hour in still water. So I know how fast the boat can travel without anything helping it, like a current pushing it. It travels 150 miles upstream in a river against the current. So the current is fighting against it and then returns to its starting location, which means as it returns, the current is helping it or pushing it along. So the total time for the trip was 10 hours. What is the speed of the current? So we're going to be using this formula, distance equals velocity times speed, or D equals VT. Sometimes you'll see that as D equals RT, where R is the rate. This is the formula we're going to use. And for these problems, since we're going to be having distance given to us, we're not going to be using this to help us write it. We're going to be using time equals distance divided by velocity. So if you solve this equation for t, you would divide by velocity. So time equals distance divided by velocity. But we're going to lay that all out for you in a chart. And I would like you to use, actually in the directions of the practice problem, it tells you have to use a chart to lay this out. So we're going to call our variable c for the current speed, how fast the current of the river is moving. So let's start with the upstream. Upstream, we're traveling 150 miles. And because the current is working against us, because we're going upstream, that means we're going to take our speed. Remember, 32 was the speed that we would be moving in still water, just the speed of the boat by itself, minus the speed of the current. So however fast the current is moving, 32 minus that will tell us how fast we're moving upstream. My boat speed minus the river working against it. For going downstream, we're going to have 150 mile distance because he came back to the same location. And we're going to take my boat speed plus the current speed, because now you're going downstream, the current is pushing with you and it's making you go faster. So 32 plus c. So I have 150 divided by 32 minus c, because time equals distance divided by velocity. So my distance divided by my velocity expression, 150 divided by that. Same thing for downstream, 150 divided by its expression. So what I end up with is 150 over 32 minus c plus 150 over 32 plus c. When I add those two together, the distance it took to go upstream plus the distance it takes to go downstream, we were told that the total time to do the entire trip was 10 hours. So it took 10 hours to go up and back. Now that doesn't mean 5 hours up, 5 hours back, because we're moving slower upstream and we're moving faster downstream. So we just know that those two expressions together, the amount of time that it took me to do the upstream, represented by this expression, plus the amount of time it took to do the trip downstream, which is that expression, has to equal a total of 10. And again, I'm only going to give you 2 problems. We can only do so much with this without being in school. So the 2 problems are going to be very similar to this one to help you set it up. We just don't have the time or the ability to do more than that. So here's my setup. Once I get this set up, then we're just like what we were in the yesterday's lesson with solving. We're going to be solving by multiplying everything by the common denominator. Now these 2 are very unique. Even though they're very similar, they are completely unique expressions. So the common denominator would have to include both of them. So I'm going to multiply all 3 terms by this common denominator of these 2 terms. So let's deal with the first fraction. When I multiply the common denominator by the first fraction, it's the 32 minus c that cancels, which would leave me with 150 times 32 plus c. Now when I do it for the second fraction, 32 plus c is what will cancel out. So I have 150 times 32 minus c, because the 32 plus c canceled. And over here, I have 10 times, well, nothing cancels, 32 minus c times 32 plus c. 10 times that, well, that's a conjugate rule. 32 times 32 is 1024, minus, now we know the middle terms will cancel because it's a conjugate, c times c, or c squared. Now there's one unique thing happening in this one. It doesn't happen in every single problem, but because each of these terms is divisible by 10, let's divide everything by 10. So if I divide this by 10, it gets rid of the 10. When I divide this whole term, this is one term, by 10, 150 divided by 10 is 15. Same thing here, this whole term divided by 10. It just reduces the numbers down, makes it a little easier to work with. So what I have now is some distributing to do. So when I distribute this out, 15 times 32, 15 times c, 15 times 32, 15 times c, I end up with, a little too far, I end up with 480 plus 15c and 480 minus 15c. Well, it's kind of nice because these 15c's will cancel out. 480 plus 480 makes 960. Now we have a nice easy equation, even though it was starting to look complicated. Works out nice and easily. When I set this equal to 0, I would minus 960 from 1024. Gives me 64. That's a conjugate rule. And we can flip this around if you really want to by taking a negative out, but we can just keep it in this reverse order. A plus B, A minus B. 64, 8, and 8, C squared. So this would be 8 plus C, 8 minus C. When I solve these, 8 plus C and 8 minus C, I would get negative 8 and positive 8 using the zero product property. Negative 8 makes no sense for a speed for a river, so the answer must be 8 miles per hour. So the current of the river is moving at 8 miles per hour. Okay, I know this might be a little bit tougher, but just do the best you can with it. Set it up the same way we set it up. Follow the example. There's only 2 of them today.